will not interfere with this reaction. And suppose you want ceruloplasmin, you add that antibody specific to ceruloplasmin, and therefore only ceruloplasmin will be quantitated. That is the advantage of immunoturbidimetry, that you add a specific antibody and with that the turbid solution is produced. And the ceruloplasmin, only ceruloplasmin will be precipitated at that region, and quantitation at that particular substance can be possible. The advantage is that it is very versatile, and therefore we can say that it is a method of future that is going in the next step. That is the another advantage is that ordinary instrument, that is it is a small instrument will be used for that. One particular point to be remembered is that when you take, let us say, in a test, 5 test tubes, same quantity of antibody, and to that increasing quantity of antigen is added, 1 milligram, 2 milligram, 3 milligram, like that, and incubator is added. Such a thing will be noticed. That is the initial, when the lower quantity of antigen, that there will be small precipitate. The same thing happens in large quantity of antigen also. Let us say this can be made into a graphical representation, that the precipitation is taken in the quantitation is taken in the y-axis, antigen concentration is in the x-axis, and then you will get such a curve that this the first part is the antibody axis, the middle region is the equivalence, that is antigen and antibody are equal, and then there will be maximum precipitation at that time, and then there will be a lesser and lesser precipitation, that is called antigen axis. And this is what this is the difficult area in this particular. And now this is the area where the measuring zone. That is, more and more quantitation is possible. Quantitation is possible only in that area. That is, this part I have already told, that lattice formation is required. That is, antigens, many antigen and antibody molecules are made, then only that a turbidity will be produced and precipitated at the equivalent concentration. Now we go for the light scattering effect. The scattering is a physical phenomenon, and that depends on the particle size, wavelength, distance of the particle or the path of the light, concentration of particles, and molecular weight of the particles. So molecular weight and the particle size, they will go hand in hand. And then that is the scattering. The scattering of the light can be of any angle. Theoretically, that can be of any angle. And this is the turbidimetry. I had already told that light is passed through and the transmitted light is taken, the turbidimetry. Whereas in the nephelometry, original machines, that was taken as the 90-degree detector, that is scattering. Light is scattered, and scattered light is taken at 90 degree, and detector is placed there. And of course, modern way that it is usually taken as 120 degree, that is called forward scatter detector. And in the usual system, that at that particular area, most of the scattering is taking place at that region, and that is why in modern instruments it is 120 degree is taken. The forward scatter is taken. Now one more addition, that is the rate nephelometry. If you remember our original colorimetry, that there is color reaction is taking place after, let us say, 10 minutes, the color reaction is completed. Then that is called the end point. Instead of end point, the modern machines will take a rate. That is 1 minute that the rate is, the color is taken, and after second minute another quantitation is taken, and that graph can be made by the machine itself, and therefore that is quicker, and that is the best way of doing that. That is called a rate reaction. The same thing is principle is made into nephelometry also, and modern versions rate nephelometry is usually done. That eliminates the need for sample blanking, etc. There are also other advantages because of that. And this is the nephelometry part, and this is the, this part is all. Now this is the difference between nephelometry and turbidimetry. Nephelometry is scattered light, turbidimetry is unscattered light. And nephelometry usually takes fine particles, turbidimetry coarse particles. Nephelometry usually takes laser and turbidimetry ordinary light, but it can be made laser also. The nephelometry usually is in the 60 degree, 90 degree or 120 degree, whereas turbidimetry is always 180 degree. The most important part with regard to the clinical laboratory aspect, that nephelometry is more sensitive, and therefore we can quantitate substances of lesser concentration, such as, let us say an example, that the 20 milligram or 10 milligram like that. Whereas turbidimetry is less sensitive and therefore needs higher concentration, let us say 100 milligram or 200 milligram like that. Turbidimetry and nephelometry has been developed many decades back, such as 20 or 30, 40 years back, machines were available. Nephelometry was not very popular because of the cost of the instrument. A very good instrument needs 20, 30 lakhs of rupees, and therefore only high-end region that A-class laboratories could afford for that. Turbidimetry was not very popular because lack of sensitivity, because the lower concentration could not be quantitated because of that. And turbidimetry offers high linearity, nephelometry offers greater sensitivity. Same reason, turbidimetry is used to determine proteins present in higher concentration, hundreds to 200, 300 milligram like that, whereas nephelometry is used to determine 1 milligram, 2 milligram, 10 milligram, 20 milligram like that. Of course, nephelometry, turbidimetry, both good machines are available in this thing. Now, therefore, we were thinking why we could not combine these two things together. Nephelometry and turbidimetry. Nephelometry is the 90 degree detector is or 120 degree machine is taken. Therefore, it will be ideal if we could combine the turbidimetry and nephelometry. This innovative technology will have the advantage of both these techniques. And that we have started with the MISPA I2, that is a semi-auto analyzer. We have to add with the serum by hand in that, whereas MISPA I3, which is kept there, that is scattered based automatic specific protein analyzer. And see, the great advantage in this, that both nephelometry and turbidimetry is there, but the machine itself will select which is the best one. That is, if you want a ceruloplasmin, automatically that will go for nephelometry. But if you want, let us say, some other plasma protein having 300 milligram, 400 milligram, something like that, then that will automatically select the turbidimetry. Then prozone detection, I had told that a prozone reaction, that when there is quantitation is, antigen quantity is more, then there will be lesser precipitation part, and that is prozone. That particular reaction can be identified by this machine. Of course, quality control is there. 25 different protein parameters can be identified, quantitated by this machine. Something like cardiac markers, anemia markers, etc. Just one thing with regard to the recently introduced the HDL and LDL, we were known for about 20 years back, that difference. Nowadays, it is better to go for ApoA1 and ApoB100. Why this difference? Because let us say if you take 1000 molecules of LDL, the molecules are different. Some LDL molecule is a smaller one, some are larger one. Some molecules will have more lipid content, some lesser lipid content, etc. Therefore, you do the LDL reaction, you get a result, but interpretation may be a little difficult. You don't know what particular molecule has been precipitated in that. That is why we go for ApoB100. It is the protein part. Therefore, protein part content is more or less similar, same in almost all the molecules, and therefore we will get accurate quantitation if we go for
this particular protein molecules. That is.
So we usually talk about ratios also. A1.
Yeah. That A1 and A2. That is correct. The immunological markers, there are many general protein markers, and then cystatin C like that. Diabetes markers, HbA1c.
For ratio, do we have any normal range as such?
Pardon me?
The ratio. Lipoprotein A1 and A3.
Yes.
Do we have particular cutoff for?
Yeah. It is I think 1:3 or something like that. There is a cut value. Normal. I just wanted to go this HbA1c, that was a reaction. There we introduce one more, that is latex is added. The other thing that is you take the serum and specific antibody, that will give some color, some turbidity. Whereas HbA1c, the point is that if you take 100 molecules of hemoglobin, only 4 or 5 molecules are of HbA1c. Therefore, that needs very specific antibody, and that only very small quantity of antigen and antibody will be there. Therefore, you will not get an ideal turbidity there. That is why we wanted to add the turbidity more by latex agglutination. Therefore, latex particles will also be added there. This is a reaction in the x-axis, that the MISPA-I2 concentration of HbA1c. Right, y-axis, that is the HPLC, that is the standard reaction. Of course, HPLC, the machine will cost about 5 lakhs, whereas MISPA-I2 is only 1 lakh. And therefore, that you can see that it is scatter plot is the same, that you will get almost identical version or the quantity of HbA1c. Similarly, other lipoprotein A, microglobulin, C-reactive protein, IgE, etc., all these are well quantitated. This is glycated hemoglobin. I don't want the seniors to tell something like that. That is.
This HbA1c, what we have found is many samples have got value more than 13. So, do you have any methods to quantify that?
Our upper limit is 12, I think.
Yes.
Upper limit is 12. Yes.
That value comes above 13.
Yeah. You see, the main problem is in that region, clinically, that it is 12 or 13. Of course, it is the same. It is very high.
We need not quantify that.
Our upper value is 12. Of course, it can go 13, 14 like that. With a usual normal value less than 6, well controlled diabetes 6 to 7, partially controlled, then uncontrolled 8 to 10, of course, still more. It is very, very uncontrolled. Therefore, the retinopathy, and this is, and the MISPA-I2 and I3, they got a lot of awards on that because of new innovation in that. With that, I remain. Thank you.
Thank you, sir. It was very nice lecture, and it actually enlightened us about MISPA-I2. I had sent a demo, but the theoretical part was very much clear with your lecture.
Yeah.
And the basic difference between turbidimetry and nephelometry also you have elaborated very well.
You have the machine if you want. We can have a look at the machine if you want. We can have also a presentation if you want the machine.
Yeah, I think we should. We had, I think, another lecture also. Or
Yeah,
I think the machine demo, I think.
No, that demo you can.
like to see.
So,
Yes.
first I will give the certificate to sir. I take this opportunity on behalf of HPLC, please. Really a nice lecture. On behalf of HPLC, I present this certificate to you. So please, nice speak with you. Thank you. It was an honor to have you there. So we are going to do demo here.
Yeah.
Let's do it then.
Yeah.
Yeah.